An insurance company has found that 1% of all applicants for life insurance have diabetes. Calculate the probability that 5 or fewer of 200 randomly selected applicants have diabetes. So this is a binomial distribution, and it's 200, p is 0.01, and we have to calculate 5 or fewer, so x is less than or equal to 5. So we know the binomial PDF is n combination x, p power x minus p power n minus x, and n is 200 as we said, p is 0.01, so 1 minus p would be 0.99, and probability x less than or equal to 5 would basically be f0 plus f1 plus so on up to f5, and then we substitute x equals 0, 1, 2, 3, 4, and 5 in this formula, and we get 0.98. Now, while doing this calculation, it would be a bit tedious, particularly because of calculating these combinations along the way. So it's possible that in a problem like this, they may tell you that use Poisson approximation to do it. But even if they don't, in general, when n is greater than 20 and either np is less than 5 or n times 1 minus p is less than 5, then a binomial distribution can be very well approximated by a Poisson distribution. And the resulting calculations, as we'll just see, are much less tedious. So the first step is to calculate the mean, and we know that for binomial, the mean is np, m is equal to np, so m is 200, p is 0.01, so the mean is 2, which is already less than 5, so we are meeting this condition, np is less than 5, and 200 is greater than 20, so we can use Poisson approximation here. So we know the Poisson formula is m power x e power negative m over m factorial. So once again, this time, e power negative m will always be e power negative 2 for all of the 5 terms. And then basically it's just 2 power 0 over 0 factorial plus 2 power 1 over 1 factorial and so on up to 2 power 5 over 5 factorial. And this is a much easier calculation, as you can check for yourself, than the binomial one. And to 2 decimal places, this also gives 0.98. So there's a slight difference in the 3rd decimal place, 0.984 versus 0.983. And in general, you can be, like we said, if it appears on the exam, you can never go wrong as long as you choose binomial. But if you're short of time and these conditions are met, and as a rule of thumb, if the answer choices differ by 3 or more in the 2nd decimal place, then you can be reasonably sure that you will hit the right answer with the Poisson approximation. So here you see the difference between 85 and 88 is 3 in the 3rd decimal place and so on. So here it's 4. So we at least have a difference of 3. But if the difference was 1, so like you had choices like 0.98, 0.97, and 0.99, then it's dangerous to use the Poisson approximation, unless, of course, the SOA is telling you that they want you to use it or you are allowed to use it. Then, of course, you can't go wrong with the Poisson. Okay, so 0.98 was choice E.